The electrical system is now complete. You can see I've got the headlights on. As we come in closer, we've got the full wire harness in place now. This is a full custom wire harness, not one that I bought from Painless or American Wire. I developed it myself. Coming all the way back. Now, a couple of things I did on this one, just in my overall sort of, you might say, strategy of how I wired it. You'll see down in here there's a lot of wires. And what I've done is I've taken all my connections and put them right here from the Raptor donor. And this is so I can literally disconnect the Raptor donor from the rest of the vehicle. If you remember, there are 6 isolators here. You take out the 6 isolators and the subframe unbolts, the rear subframe unbolts from the main chassis. All my electrical connections are here. You just unsnap them. I've got one brake line down here, along with my brake pressure switch for my brake light. So even my brake lines disconnect there. My coolant lines disconnect right there, and my fuel lines disconnect. Got to drop the tank and disconnect them there. So I could literally pull the rear subframe off of this in probably about 45 minutes. So here is the dashboard. You can see down below, we've got a set of indicator lights. This came directly from the Raptor 700, so I just reused it and extended the wiring so it would fit all the way up here in front of the driver. You can see it's got the typical type of indicator lights. We've got reverse, light, neutral, one if your engine is running too hot. There's one if there's a general engine problem. This does have an ECU on it, so it does tell you whether something is wrong with, say, with the fuel injection. And the fuel light over there as well. Up top, we've got a Trailtech Vapor unit, and that's got a speedometer, tachometer, temperature gauge, odometer, and a few other useful gauges inside it. On each side of the vapor gauge, you'll see we've got some more indicator lights. The ones on the top, left or right, are the left and right signal lights. And then on the one on the bottom over there, bottom left side, is high beam indicator. I've got one extra space over here on bottom right. But very simple, very small, lightweight, and it all works. One of the other tasks on the electrical system was making the controls much more simple than they were on the original donor Raptor. For example, just to start the vehicle, it checked through front brake switch, rear brake switch, through a clutch engagement safety switch. There was an on key, there was a run or off, there was a kill switch. So it was a matter of taking all those controls and simplify them into a single automotive style ignition key. Okay, and I think as you can see here, I'll turn it on. You can see all my gauges are working. To make the other controls simple, I put a number of them right here on the steering wheel. Of course, in the center, you've got the horn, but you see there's 3 other silver buttons on here. The buttons on the left and the right are your left and right signals, and the one at the bottom is the high-low beam. And then if you want to use your emergency brakes, in other words, having both sides flashing, the signals are wired, so you simply press both signal buttons and you'll get all your lights flashing, and what we would normally call a 4-way flasher. When I press this button, it turns that light on. Press this one, left lights come on. Press the one at the bottom, and you'll be able to see the high beams come on, and of course a horn. Now this car doesn't have any doors, so I've got a way where you kind of come up over the edge of it and get into the car, which means for some people it may be hard to get into with a steering wheel. So I've got on a quick disconnect, as you can see. Even no wires, you can see that it's a remote. Press the other one. And of course, high beams and low beams. So here's some more details on the wireless controls that are mounted on the steering wheel. I bought a 4-channel system that has a remote, small remote. This is actually quite big in the picture. It's blown up to be quite big, but it's the size of a very small key fob, along with 4 wireless receivers that are mounted in the car. So I took that key fob, tore it apart, and you can see there's 4 buttons here, A, B, C, and D. And for each switch, I wired in a set of wires, so each of the switches could be controlled by a button outside the fob. So that's why there's 8 wires coming out of this. And in this photo, these wires look like they're pretty heavy duty, but like I say, this is quite a close-up. This is a small unit. And they were quite fine gauge wires. So here are the receivers that are mounted in the car. There's, like I say, 4 channels, and there's 2 different kinds of wireless receivers. You'll see on one of them there's an M. M stands for momentary, and that's the one that I used for the horn. So in other words, the way the momentary wireless channel works is you press the horn button, and of course the horn goes, you release the horn button, and the horn stops. In other words, it only stays closed momentarily while you've got the button pressed. The other 3 channels work in a toggle fashion. And those are the ones I use for things like the turn signals and the high-low beam button as well. And those are toggled. In other words, you press the button, and the switch closes and stays closed until you press the button again, and it toggles open. So toggle close, toggle open. And like I say, I use those for the turn signals and for the high-low beam change. And here is the system mounted on the back of the steering wheel. This is the side you don't see, and it faces down towards the dashboard, so you really don't see this unless you pull off the steering wheel and just look at the back of it. But you can see the key fob here has been mounted. It's actually been cut into the aluminum housing of the quick disconnect, so it's very unobtrusive. You can see how the buttons are mounted from the back. You can see the wires actually go through the hub and then out to the turn signal buttons. And you can kind of barely see the high beam, low beam button there at the base as well. One of the other challenges was just dealing with the amount of power that the alternator puts out on the donor Raptor. Overall, it puts out about 20 amps, and it had devoted up to 15 amps for all the lighting. So what I did, I went to all LED lighting, all the indicators as well as the headlights. And I was very happy to see that when I actually measured what the lights were consuming, all together with highs and low beams on and all the indicator lights on, it only pulled about 4.5 amps. So I'm well within what that alternator can produce, and I shouldn't have any problems with battery going dead. When I read the forums, I see a raging debate on whether it's better to solder or to crimp connections. And it's almost a religious war. But I say it depends. It depends on what you're doing. For example, I had to extend my warning light. These are the warning lights that came on the original donor, Raptor 700. And I need to extend it so I can put it up on the front dashboard in front of me. In order to do that, of course, you add wires to it, and I've already done the extension here. And you can see when I'm doing a connection in line, I like to solder. And that's because if you were to put a bunch of crimp connectors in here, it would really be bulky and just be kind of very, very awkward. So I do solder, and then I put a little piece of heat shrink over the top of it. And you'll also know, particularly when you're doing a number of these, is these are staggered. In other words, I don't put them all in the same place. And that spreads out. Even these solders take up a little bit more room. And if you spread them out, you'll have a much more uniform wiring harness. That, and if two of them come apart, they'll never touch. So that's soldering. You'll see over here, I have a lot of terminals. I use a lot of terminals. When it comes to connecting to an endpoint, whether it's a ground or onto a component, I use crimp-on connectors. In the past, I was an aircraft electronics technician in the Air Force. Actually, I worked on Air Force One there in Washington, D.C., the president's plane. And I figure if it's good enough for the president, it's good enough for my projects as well. Now, I do hear about people having difficulty with crimped-on connectors in that they don't stay or they come loose on them and they just don't understand what's going on. And what I find is they're using a set of crimpers like this. These are incorrect crimpers for insulated terminals. This type of crimper can be used with these types of connectors, uninsulated. That's what it's made for, okay? So you'll see that there's two size crimps. The small one is for where the wires actually crimp into the pin, and the larger one is for the barrel behind that actually clamps on the insulation just to stabilize it. So here's what I'm talking about. You'll see it has two crimps on it. The first one towards the pin, you can see that's where my finger is where the wire crimps in, and the larger one there is for the wire. All right? So these are for uninsulated type of connectors. And whenever possible, I use an insulated connector, terminal, just because it's a little safer and it's less chance of something being shocked. When you're using insulated connectors, you need a crimper like this. It is specifically for insulated connectors. You'll see there's 3 different sizes. The smallest one is for red terminals. In fact, there's colors on here, and that's for the smallest terminals you'll see here in the pack. And then there's also blue, which is the next size larger, and yellow. So this is built so it's a ratchet type connector, okay? And you can hear it click, and it won't release until you click it all the way. And then it releases. And the reason for that is to just ensure that you've got a good crimp. In other words, it will not let you release it until you've crimped it down all the way and you've given it a proper crimp. And I promise you, if you use this tool, these terminals will stay on. This is the first of 2 episodes on the electrical aspects of the Tiger 700 project. The next episode will cover the specific changes I made to the circuitry to make it all work.
See you then.